Hey YouTube, welcome to the second part of my tutorial about turning an inkjet printer into a plotter. Just your weekend project. In this part I will cover the code that I've got ready up until now. It's definitely not finished. I had a lot of issues that I needed to fix and solve, things about accuracy and the motor slipping, all sorts of bugs that I'm still busy with solving. The first part I explained how to prepare the printer, which printers are best for it, how to strip it down, test it, get it all ready to connect your own microcontroller to it. In this second part I will cover the code that is ready up until now. For now the code can only produce straight lines, so X and Y movements, still no diagonal movement and still no circles because I am missing a third Arduino. So let's go about it. Before we go about the code, I will cover some issues that I solved regarding accuracy. The first thing that caused some great deal of inaccuracies in my mechanism is this cable here. I didn't notice that when the unit moves, the cable sort of slightly rests on this the position strip here, and that caused just erratic behavior. One time the printer would just print out straight lines, and it would seem that it behaves normally and everything is working properly, and then in an instance it would just do something crazy, like go all the way to the other side or something that is not supposed to happen. And I was busy with it quite a long time trying to solve it through code. I thought maybe it has to do with the code or with the sensors, but eventually it was just this cable strip. The original one was thicker, and this one I've cut it down and it doesn't hold itself properly. So at a certain point, some random spots where the carriage unit would sit, this cable would rest on the position strip, just slightly nudging the strip from its original position in the sensor, and that would cause everything to go wrong. So I sort of removed this cable. I didn't remove it, but I just took it out of its current arrangement, and it's just sitting freely now. And that solved part of the problems. I'm getting more accurate results now, but still it's definitely not in a place where I can say I can get 100% accuracy from this device. I don't think that I will ever get 100% accuracy, but yeah, it's something to look forward for, to strive for. In any case, that was one issue that I thought about sharing. And the next thing, let's look at the circuit that I've built. Some people ask me what does the circuit look like. So I've taken a picture. This is the original circuit up until now that I'm using. It's very basic. You can see the diagram right here. Let's start with this image right here. Here you can see the L293, and there is also a 5-volt regulator because I'm feeding it with 12 volts. Here you can see the transistor for the pen, which will lower and raise the pen. All these wires here, they just come from the sensors and the motors, extension wires. It's a big mess, but there's nothing really significant in this area, just the driver, the tip 121, and this voltage regulator. Aside from that, here are the two Arduinos. This is for the X and this is for the Y. Here you can see some test points from the stage that I was testing it. I just shortcutted the wires, and that's how I solve bugs when I have them and I want to just take things step by step. Right here you see a loose ATmega 8 that I had. I'm using it as a third controller, and it's really hell to debug. Every time that I want to make any small change, I need to basically disconnect this Arduino here or this one, upload an ISP to it, connect this chip, upload the firmware to it, and then reconnect everything. That's because I only have these two. I don't have a dedicated programmer, and I have to use one of these Arduinos to program this ATmega. So that's a major issue when it comes to just efficiently working on this project, and that's why I've decided to make this video now, because I don't have a third Arduino and my financial state doesn't allow me to purchase it right now with some other things. So best to get this part of the code out of the way, and later there will also be a third part that I will show you more things that I got with the third Arduino. So the circuit itself, the image that you saw, this sort of represents it. We have the two Arduinos right here, the Y and the X. The third one, which synchronizes the two, the L293. This is the circuit for the pen. It will raise and lower the pen. Now this setup sort of applies to everything that I got so far. So for example, these two Arduinos, they have a pen output, but the pen should be on this third one. But because I don't have a third one and I just wanted to test them out, then I sort of went around it and I just placed a pen output with a procedure in each one of the axes, but it doesn't need to be like that. The pen should be here, and also the homing sensors, they should be on this third Arduino. So everything you see here only applies to the code that I have so far already, and this code you will also find a link to download it in the description. It's 3 pieces, one for the Y, one for the X, and a small bit of code just for the microcontroller for the ATmega, so that I can sync the two. Here you can see the pen output, and again these two diodes here, you don't really need them. There will only be a single input that comes from this third Arduino. But since I don't have it and I didn't want to bother with starting to write code that I have difficulties to debug, I added these two diodes, and then each one of these controllers, they will just send the command to raise and lower the pen when their turn to operate comes. All the pull down resistors here, they're all 1K. On the sensors, these ones and these ones, I would put 10K pull downs. They make it a little bit smoother, even though that the sensors themselves they have these pull downs in the sensor itself, but it's always good to add them and get more accurate results. So this is the circuit, and you will find it in the link to download it with the source code. A little bit about how it works. So what this controller does, it simply it starts with the X, and then it goes to the Y, and then the X, and then the Y, and that's what it does. You can't, for example, carry out two X's, so let's say going forward and then going backwards. If you want to go forward and backward, then there will be an X movement, then the Y movement will basically be a 0 that will be carried out, and then again there will be an X movement to go back. So this is what this third controller does. The code for it is very basic. I didn't work on it again. I only made some code that will just synchronize these two and get them to work, and you will see it shortly. Once a command is carried out, for example, we have here ready, enable, disable, next, and home, which is currently not connected. These ones, they're pretty much clear. The sensors, the motor outputs, and an enable output for the L293. The way that it works is that this microcontroller, or this one, they're both pretty much the same, only with slight changes inside for each function. This microcontroller will send out a output from this ready, and once it's ready, it's high. This microcontroller knows that this one is ready. It will check that this other microcontroller, the Y, is also ready, so that it knows that it's still not carrying out the previous movement or still busy with another movement, and each one on its turn. Once both are in a ready state, the command will be issued for the next command here that is provided, that also the enable is high. So if the enable is not high on the microcontroller, the next command will not be carried out. And once the command is being carried out, the ready pin will go low, it will be low. This microcontroller will wait until this one has finished everything that it needs to do, and then it will move to this one. On the Y, since it's the last step that it will be carried out, there is also a stop pin. It's a temporary thing, just again to get this setup to work. And once it reaches the last Y, then it will just send out a high to stop the sequence on this third Arduino. And that's pretty much it. Once again, everything that you see here is a temporary sort of setup just to get this thing to run with 2 Arduinos instead of 3 and in a proper way. Let's have a look at the code. The code here will start. There are, again, the code for the X and Y is pretty much the same, only that I had to make some changes just to adapt the whole thing without a third controller. So we have the pins here, the sensor pins, their interrupts. They're used the pins 2 and 3 on the Arduino. Here we have sample pattern, and this is what you saw at the beginning of the video. What you saw at the beginning of the video, that's something that I shot about a week ago when I was just testing these patterns, and there is some deal of inaccuracy there. I fixed that issue, so the motors, they don't slip anymore, and we will see that in a moment. That's yeah, pretty much it. Everything works exactly how I explained it in the circuit. Some things in the loop, we're basically only we're only executing code if the microcontroller is not in a live state, so not carrying out a movement and just waiting for the commands. Here we have the home position, home calibration, and I just put it out now because I commented it out because I don't test it yet. These are the 2 interrupt functions. They will change the states, and then they will check the states of A and B, and if A is high and B is low, then a count will be made. In principle, you need to count all the steps to get the highest degree of accuracy. So you need to count all 4 stages. Then you will also know at which direction the motor goes. But it's less important for me now, so I'm just counting 1 state, and it's sufficient. Here you can see that once it's live, it basically it will count the steps. If it reaches the position of the count, it will carry out the fast stop. The fast stop procedure here, it will solve out the issues of the motors slipping, and it will solve it by basically just giving out a reverse polarity. and it will cause the motor briefly to spin on the other direction. Here I have a delay of 500, but it's too much. It was just something that I was testing, so 200 is enough. What else? There is a lot of debugging code still in here. I leave everything. You can just go through it. You can remove whatever you want. The pen controller, the way that it works, not the pen, but everything else, is that if we look at the input readings, once we have a high on the enable, then the entire microcontroller will go into an enable state. Then it will prepare the next move right here. It will just put all the length inside. It will check if it needs to go left or right. It will set the speed of the motor, the pen state. It will enable the L293, and also it will set the ready pin to high. And there is also a flag here that it has been prepped so that this function doesn't repeat itself every time. Once that has happened, and again the microcontroller is still in an enabled state, then we check if we get a signal on the next pin, if it's high, and if it's enabled, and if the length of the movement is not 0, then it will execute the movement. Once it's executed, the microcontroller goes into a busy state. The live flag goes high. The pen controller is being checked, so if it needs to be lowered or raised, the motor state is being set accordingly. And from here on, everything is carried out by these interrupts until it reaches the right position. Then it calls in a stop, a fast stop for the driver, and a stop procedure, which will then go to the next instruction. So it will raise the index for the array of instructions. It will again lower the flag for the prepare function so that we can carry out this thing again. If the length of the array is greater, then it will reset it. Some debugging code, and yeah, that's pretty much it. Disabling function, some home calibration functions which I commented out because I didn't connect them yet. That's about it. That is the X. That is the code for the X. The code for the Y looks almost the same. It will have different values here, since the X and the Y, they have different ratios of counting. So it's about 1 to 7, 1 to 7.5. Nothing precise, but that's roughly the way that they will count. So for example, on the X, a movement of 150 will be equivalent to a Y movement of about 1125. These are the pen states. They're both exactly the same on the X and the Y. Simply because I was lazy, I just copied and pasted them. There is a lot of inefficiency in these sort of patterns, but the final goal is that the third Arduino is connected to the computer, and from the computer all these measurements are being sent. So this is just a sort of hard-coded fixed thing for testing. And yeah, you can download this code, you can review it, you can change it in any way you want, but you see that it's pretty much the same. I marked places where essentially these things, they need to go into the third controller. They're just here temporarily. They don't need to be here, but again, I don't have it. The third controller, it has a very basic code in it, just this piece, which again, it will first of all, it will check that it's in an enabled state. and then according to the state, either Y or X needs to be executed next. It will check if both pins are ready, and if they are, then it will execute the next step. There are a lot of delays here in the middle because it's easier to debug and it's easier to follow the patterns that the printer will do, and then just follow them and see that they're carried out correctly. But the machine can go much faster than the delays. Altogether there is about 1.2 second of delay between each step. That was the code part. Just to show you these patterns here, how I've plotted them and how the machine will carry them out. If we go to this image right here, you can see how basically things are being plotted. The red dots are just places where the pen will not be lowered, and the blue ones are places where the pen has lowered after carrying out the command. So what you saw at the beginning of the video, we have the starting position here, and the first movement 500. At the end of this movement, the carriage will be here, and this is an X movement. So if we look at the X, you see that the first movement is 500. So there's no like movement to the zero there's no movement like the reach here. This will be part of this function, which is currently commented out. Go to start, it will just go to the starting position. Next, once it's carried out an X, then it will carry out a Y, and the Y again 500, different ratios. It will you can see it right here, the first 500 for the Y. Then yeah, we reached Y1, so X1, Y1. These two will be like a single step for the third microcontroller, so it will just carry out XY, 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 it will repeat it. From this point, X2, the pen will lower. The pen will lower, you can see it right here. So the first movement, the pen state was 0. The second movement, which is 150, the pen state will be 1, so the pen will be lowered, and at the end of this movement the result will be that this line has been drawn, and then the carriage will be here. Now there is some inefficiency in this pattern. Here you see there is a X2 and Y2. Because I could have done like a minus Y, go to here, and then a minus X, but since I needed to implement a state of 0, so a state where one axis is not carried out, then I did it this way, where now the Y2 will be 0, so it will not move, and then there will be again an X3 movement, which will bring it over here, and then a minus Y movement, which is Y3, and it will be here, and again X4, since we don't need at this point we don't need to make an X movement, so X4 is simply 0. You can see it also here that X4 is 0. Y4 will be a movement, and again it has the pen, and that's how it carries out this entire pattern, just going XY, XY, XY. It's again, there are inefficiencies here. Here you can see that we have a meeting, we have basically 3 points that sit on the exact same thing. So you can plot it differently, but all in all, eventually you will also reach places where you need to carry out a 0, and the machine will just halt and wait, and then carry out the next axis. So yeah, that was it about the code. Again, you can download, you will find a link in the description. You can download this code, you can use it, you can review it. By the way, the circuit for the L293, it's just here from the data sheet. You can download this data sheet and you can find this circuit right here. It just has these 4 diodes and everything else is carried out by the chip. And yeah, that was the second part. In the future, I don't know when, I will release a third part once I have all the components and everything that I need, the third Arduino. And it sounds kind of trivial, like yeah, how much does it cost? But my financial state only allows me to make free things with whatever I have and the free YouTube platform, and that's the only thing that I can give you right now, but it will come in the future. So I hope you liked it, and that's it. Thank you for watching.